Okay, good morning, everyone. Uh, my apologies for the problems earlier, where I definitely got the time wrong. That's what we call in the business a off by one error. Um, so, I'm just gonna take a couple minutes here to double check that everything appears to be working correctly, and we will get started once a couple more people have joined. So, hold tight for that. Yeah, okay. Everything seems to be in order. I'm just going to set up my personal monitor for the stream over there. Yep, remember to fill out your attendance. The link is on the Discord, so please go do that. But aside from that, we're going to get started on today's content. So this is, for clarity, the Saturday section of Session 6 of the Schulich Ignite program. And we are going to get started on today's presentation. So today we're pretty much only going to be talking about one thing, and that's functions. Let me turn on my pointer here. And yeah, let me see also if I can get Windows to behave. Again, my apologies everyone for the technical issues I'm experiencing this morning. Okay, so yes, today we're going to be talking about functions. Can we confirm that the audio is working? Because my system is reporting that I have a bitrate of 0. So I'm just going to wait until I get confirmation that it's working, or don't. Audio is good. Fantastic. Thank you, Richard. Okay. Yes, functions. So, functions are a way for you to package code together into reusable chunk of code with a name. They let you split up your program into a bunch of smaller parts that are a lot easier to understand individually than a whole big block of code is all at once. So you may have noticed if you looked through any of the more complicated or the challenge examples at the ends of the previous sessions, oftentimes they end up with these really, really big draw loops. They're just massive, massive blocks of code. And a lot of that is just doing the same thing over and over again on different inputs. So functions make our lives easier by letting us reuse code and break it out into bits that each have a name and that do a thing, so that you don't need to write the same things over and over again, and also to help you kind of conceptually keep things well organized. So one example that we have, this is a somewhat subtle example on why it's wrong, but it mostly gets the idea across. So the idea for, if you take a vending machine pretty much needs to do just a few things. It needs to wait for somebody to put in money, and then once somebody's put in money, it needs to take in their choice for food, and once they've put in money and they've put in their choice, then it needs to dispense the chosen item if they've put in enough money. And you could do that all in one big program loop. But you could also break that out into 3 different functions, one of which is count the amount of money that they put in. Another is take in the choice of food. And then the final one would be something along the lines of dispense the chosen item if there's enough money. So we've already been using actually a bunch of functions, and we've been using them kind of like commands, things that we tell the computer to do. And we've been using these functions without ever really kind of explaining that they're functions. And the reason for that is we hadn't explained what functions were yet. But we're now going to have another look at these within the context of functions. So the ones on the screen, like print and ellipse and fill, those are all functions predefined by the processing language. They do a single thing for us, right? Print prints whatever string we give it. Ellipse draws a circle somewhere on the screen, and fill changes how we want to draw subsequent things on the screen. So all of these just kind of do something. But did I skip a slide? Hold on, sorry. Nope. There we go. Some other functions give us back what's called a return value, and we've been using these as well. So here are a couple ones that are predefined. So we have max and len and random and sort. All of these are also functions, and these all have a return value. They give us back something. So max value gives us whatever the larger of the two input numbers is. Len gives us the length of the list that we give it. Random gives us a random number between 0 and whatever number we give it. And sort gives us a sorted copy of whatever list we give it. And so we've used a couple of these, but we haven't, again, we haven't really explained that they're functions or how functions work or why they do the things that they do. So again, we're going to have another look at that today. One of the other actually really important functions that we've been using a lot is the function range, right? So whenever we want to iterate over a sequence of numbers, right? 1, 2, 3, etc. We use the function range, and that gives us a list that is 0 through to the whatever number we give it minus 1. And so that's a function that we've been using, again, without kind of really calling it that or really explaining what the return value means. So that's, hopefully at the end of today's session, you'll have a better idea of why these things behave the way they do, given what we talk about with functions. So we can also write our own functions, which is really kind of the important bit, because the predefined functions are good and they're nice, but they do one thing, and we can't really change what they do. If we want to create our own function that does a thing, this is how we do it. We use the keyword def, which will show up in green in your editor. Then we give the function a name, and then we tell it what parameters we want to give it. So you can see over on the right, we have the function checklist. So the def keyword is required, the name is required, a body is required, and that's some code that will go in here where we have this comment saying function body. I'm also just going to hide my camera real quick just so that we can see the whole picture. 1 second. There we go. So yeah, and then at the end there's a statement that's return value, and we'll get into that in just a minute. The def statement, the name, and the function body are all required, but the parameters and the return statement are not required. Yeah, thanks for pointing that out, guys. There's something of a lag. I didn't realize quite how bad that was. Yes, so that's pretty much what we've got going on here, right? All of these parts, that's kind of what they do. And some of this probably looks familiar. We'll get into that in just a bit. So function names. Again, all functions have a name. It's what we use to call the function, and calling the function is it's the terminology for saying that we want to use this block of code. So if we wanted to use this function as it's currently defined, we would need to use the this name to call this function. Right now this function doesn't do anything, and in fact it wouldn't even work because this value is undefined. But what we would need to do if we wanted to call this is use its name. The function body describes what the function does. And this is where we put all the code for the function. I'm also just going to turn my camera back on now that I'm no longer covering anything with it. Where'd my mouse go? Maybe I'm not going to do that. All right, fine. I'll sort that out in just a second, but it's not really important for the moment, so we will leave it alone. So yes, this is where we put all of the code for our function, is within the function body. And we'll get into how we make that do things depending on its inputs in just a minute. But for the moment, we're just going to do a quick example. Now I do need to figure out where my mouse has gone. There we go. So I'm going to switch over to processing in just a second. There we go. So we're going to switch over to processing. And what we're going to do is just type in a very simple function. So we're going to call this function greeting. So again, the def keyword followed by the function's name, we need to have these parentheses here. What these do is tell processing that we don't want this function to use any parameters. They're optional, but we do still need to tell it that we don't want any. So we have to have those parentheses there. Then we're going to say print hello everyone. So this is going to be something like our first examples where they just do something. It's got no return value. It's very simple. Now we're going to say def setup, and we're going to call our function greeting. And so we do that by typing its name and then the parentheses. So this here and this here look very similar, but this one is a function declaration. It's kind of like the assignment, and these parentheses have a separate meaning from these ones. We'll get into exactly how we deal with that again in just a minute. But if we run this, we can see that in the console, we get the text, hello everyone, right there. Okay, I'm going to switch us back to our presentation. So we also have a challenge question. Again, answer this in the Discord, please, for Schulich Ignite points, judged by Richard. So setup is also a function. Can anybody determine what the function body of setup is? And while that is going on, I am just going to move on. Yep. So the next thing we want to talk about is function parameters. So these are the values that are supplied to a function, and they kind of become variables for that function. So here we have the parameter parameters, which is not particularly useful. We can have more than one parameter, and we'll explain all of that in just a second. But the important thing to note is that these act mostly like variables for that function. So we're going to do another example of a function with some parameters. And I will again switch us back over to processing. So we're going to clear out what we had previously. We're going to define a new function, greet me, and it's going to take in one parameter, name. And that's going to be the name that we want this function to greet. And what we're going to do is have it print the string hello, plus whatever the name is. And so then if we, do setup again, and we call greet me with the string Liam, because that's my name, we can see that it prints out hello Liam. And so this is one way that we can do some interesting things with these functions. So if I wanted to, instead of greeting me, I wanted to greet, say, Richard, then we can write in greet me Richard. And this says hello Liam, hello Richard. Right? And so these things are very useful, especially when this gets more complicated, right? Because you can imagine if this was, instead of being one line of code, that was 12 lines of code that I wanted to do, being able to write it just once up here and then call it twice down here is very, very useful. Okay, let's switch back to our presentation. We have another example here of a function that takes in two parameters. And so this is going to print out, sorry, we have a small error in our slides there. What this is going to do is print out the sum of the two numbers that we give it. So I'm going to, again, switch us back over to processing. Once more, I'm going to just clear out everything, and we're going to say def add, and we're going to give it two parameters. And these parameters, the way that we do more than one is we just separate them with a comma. And you can put in space. It ignores space in these parameter lists. And then what we're going to do is we're going to say sum is equal to a plus b, and then we're going to print the sum. And then we're going to do def setup, and we're going to call add. And let's do 3 and 4. And we can see that when we do that, we get the value 7 out at the bottom. We can also, interestingly, use this for other things too. So you may have noticed earlier I used plus on strings, which we kind of touched on before. But what I could do here is use add to print hello plus Liam. And we see that it actually prints out hello Liam again. That's not super important to functions. It's just kind of a nice thing to note is that sometimes these functions can be used for more than one purpose, depending on what you put in. I would be careful with this, though. It's fairly easy to break things with that. So if you have any questions, please do feel free to ask that in one of the help channels on the Discord about kind of when you can and can't do this sort of thing. I'm sure we'd all be quite happy to help you with that. We're going to transition back to our presentation again because we have, that shouldn't have shown, I think. Oh well. We have exercise 1. So we would like you to create a function that called draw snowman that draws a snowman on the screen. So we'd like you to use the function circle 3 times inside draw snowman. So what the function should take as inputs, as its parameters, is the x-coordinate of the snowman and the y-coordinate of the snowman. And you can specify those kind of relative within the snowman however you want. And then we want you to call the function inside of draw. And I'm going to give you all about 5 minutes for this, so I'm going to turn off my camera and my audio, and I'll be back with you in about 5 minutes. If you need more time to work on this, please do feel free to post that in the Discord chat. Richard is monitoring that and will keep me posted. Okay, that's been about 5 minutes for this exercise. If you have any other questions or if you had problems with this, again, please do ask in the Discord. We're all very happy to help you. You can hop into either the general channel or any of the individual help channels to ask about those. But for the moment, we're going to move onward with what we're doing today. So we're now going to talk about function return values. So we kind of touched on this, but return values are what the function passes back to the rest of your program. So return values can be pretty much anything. They can be a number, they can be a string. If you end up doing more complicated stuff and working with other data types, then they can be those as well. So they're fairly versatile things. And what they are designed to do is kind of just simplify a lot of stuff, very much the same way as functions do. So we've got a couple of examples here, which I will just switch over to processing to show you. We can see they're fairly similar. The only real difference between the two, between the two is one of them does some math in the middle there, but let's switch over to processing. So we can see, again, I'm just going to clear this out. So we're going to define these two functions. So we're going to do this first one, get my age. My birthday was just this last Thursday, and I'm now 23, so I'm going to return 23. And then we're going to define our other function, def2 plus 2. We're going to say answer equals 2 plus 2, and we're going to return the answer. We're then going to do our setup to kind of show the results of this. So def setup, and we're going to print get my age. And then the other thing we'll do is we'll just show that if we say result equals, actually, you know what? Just for a good demonstration, let's call this answer as well. We're going to say answer equals 2 plus 2. And then we're going to print answer. And so if we run this one, you can see we print 23 and then 4, which is kind of as expected. The thing I want to point out here is that this answer is totally different from this answer. And again, this is the same thing we've talked about before with scope. Again, if you're experiencing any confusion about that, please do ask on the Discord. It is a very subtle kind of concept. It's not easy to get a grasp on it. So if you are having trouble, that's a very understandable thing. In fact, in general, if you're having trouble, don't feel like any questions that you're asking are going to be dumb questions. I personally have yet to encounter a dumb question with people that I'm teaching programming. It's not an intuitive thing, and a lot of these things, they just don't make a lot of sense intuitively, and programmers forget exactly how dumb the things that we're doing are. So it's very easy for us to not even recognize what's hard or what's difficult to understand. So if there's something you're not understanding, please do ask, because that tells us something about what we're doing wrong, and it helps you get a better understanding. So really, I don't think there are any dumb questions in this sort of circumstance. That aside, we're going to transition back to our presentation. So we're going to do another example. So this one is a little bit more complicated. We're going to do some math beyond just 2 plus 2. So we're also going to use a parameter. So I'll give you just a second to read this. What we're doing is we are calculating the volume of a cube with side length 2 and then printing that. I'm going to transition back to processing. One more time, I'm going to clear this out. Another thing to note in Python, in processing, you can kind of define your function after you want to use it. So we can say def setup. We say volume is equal to calculate. Wow, that word was really hard to type for some reason. Calculate cube volume of 2. Then we're going to print a cube with side length 2 has volume. Whoops, forgot my in parentheses. And then we're going to print whatever volume we calculated. Now we need to calculate that volume, so we're going to say def calculate cube volume. We're going to pass it a parameter called side length, and we're going to return side length times side length times side length. So if we run this, we should see exactly what we expect. We'll see that processing calculates for us the volume of a cube with side length 2, which is 2 times 2 times 2, or 8. Thank you all for the birthday wishes as well. Appreciate that. So yes, the interesting thing to note here is that we have our return type, so volume gets whatever value we return from calculate cube volume, and then we can actually define our function after we use it. So processing, when you ask it to use this, it looks through your whole file to see where is this function that this person is talking about. Okay, we are going to transition back to our presentation again. So at this point, it's a natural question to ask, why would we even want to use functions? They don't seem that useful. They don't, I just have more kind of weird names to deal with. And this, again, this is a natural question to ask, and that's mostly because what we're doing is some fairly simple stuff for the sake of examples. I'm also going to just turn off my camera here. Whoops, that one. I've recently transitioned to using a drawing tablet as my main method of navigating my computer, and I'm not totally used to it, so my apologies for all of the weirdness with my mouse. So if we wanted to draw this kind of simple town that we have over on the left without using functions, we need to use the same block of code over and over and over again, because we need to set our background to white. Sorry, set our fill to white. We want to draw a rectangle. We want to draw a triangle. Then we want to set our fill to black so that we can draw our windows. And then we need to do it all again, and we need to do that for every single house that we want to draw. And we could make this a little bit more efficient by changing the order in which we did some things, but it really doesn't help all that much to just change the order, because we're only cutting out a couple of statements. On the other hand, if we use functions, this is what we get. We see it's not significantly shorter vertically, but the text is much larger, probably much easier to read too. But what we see is that in setup, we set up our size, then in draw, we draw our background, and then we draw a house 5 times. That makes perfect sense, because that's what we want to do. What we want to do is draw a house 5 times. It's not that we want to, that's what we kind of, again, it's a little bit subtle, and you can technically write code without ever using functions. It's just so much nicer. It's so much nicer to read. It's so much nicer to kind of decipher what the code means. And it's nicer to try and change things as well, right? You can imagine if instead of drawing our windows with these kind of parameters, right? If we didn't want to do that, in the previous code, let me go back one, what we would need to do is go change this line and 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 this line, and right, all of these lines. That's 10 lines we have to change for a relatively simple change to our code. Over here, if we wanted to change where our windows are, we have to change these 2 lines only. And it's just much, much easier to do that sort of changing. So it's just much nicer. And that's, if you don't get it, yeah, that's understandable. They're kind of a subtle thing to explain, but when these get really complicated, having functions is almost invaluable. And we have some of the examples at the end of the slides that kind of make that clear, But I think the main thing that I like about functions in the context of processing and in the context of processing style projects is how much nicer this looks, right? Previously, it wasn't clear what we were doing in draw, but now it's very clear what we're doing in draw. We're drawing our background and then we're drawing 5 houses, right? That's very intuitive and very clear overall. So they're really, really useful. It just makes everything so much nicer and so much easier to read. Okay. They're also very useful for changing inputs. So I am going to just kind of explain this one because we do have a challenge question at the bottom there. So I'm just going to quickly transition us to processing. I have a Huion 1060 Plus something. I don't know. I got it on Amazon because it was cheap. For reference of anyone watching, there was a question asked in chat about what drawing tablet I have. Okay, let's do this function. So we're going to do def setup, and we're going to say size, what's my screen size? 540 and 960, so that should be a quarter of my screen. Just trying to minimize the amount of time I need to waste with messing around with the processing windows after I try to run things. We're going to define draw. We're going to draw our background in black, and we're going to say C is equal to get ring count for whatever our current mouse position is, so mouse X. Then for I in range C, remember what this will do is iterate from 0 to C minus 1. We're going to say ring size is equal to 20 times C minus I, right? So when I is 0, that's going to give us 20 times C. When I is 1, it's going to give us 20 times C minus 1, etc., all the way up to when I is C minus 1, that's going to give us 20 times 1, or 20. And then we're going to draw a circle at 270 and, oh goodness, this is more math than I wanted to do at this time in the morning on a Saturday. Circle at 270, 480 with size, ring size. Then we need to do our get ring count. We need to define that. So def get ring count for our current X position. We're going to say count is equal to floor of X divided by 20 and return count. I don't know if we've talked about it. Floor is another function. What it does is it just it rounds down. So if X divided by 20 isn't an integer, so say X was 50, then X divided by 20 would be 2.5. Floor would give us 2. It just cuts everything off after the decimal. So if we run this, aha, I see my problem. I made this the wrong direction. 960, 540. And then this needs to be at 480 and 270. Yes, that's much better. So I will transition us to the sketch, which will just take me a second here. There we go. And so we can see this behaves very much like what we have on screen. It goes quite far off the screen because as I get further and further to the right of my screen, I get more, oops, I didn't actually transition. Haha, sorry about that, everyone. So again, you can see as I move my mouse, it changes the number of rings that we're drawing. So I'm going to transition us to our presentation again. We have another challenge question at the bottom of this page. So what we would like you to do is figure out a way to make each ring a different color. So we make it kind of a gradient from black to white black on the inside, white on the outside, or you can do something else if you find that more interesting, but make each ring a different color and post your answer in the Discord chat. I think Richard is handling that as well. Okay. And then after that, we have another exercise. So actually, I'm just going to go back for a quick second for this challenge. I will give you all a minute for that. I'll just hop over to the Discord to see how that's going. Yeah, pretty much if you come up with a solution to that, post it in the Discord. So Richard will kind of judge on that. Anybody who doesn't feel like working on that, I'm going to introduce our next exercise. So this exercise is using a snowman factory. So inside draw, we'd like to call our function draw snowman again, but this time using a loop. So there's your same function that you had for draw snowman. We'd like you to use it again to draw several snowmen. So we have on screen there 3 snowmen on the bottom and 1 on top. Bonus kind of exercise within this is make one of those snowmen follow your mouse X and mouse Y coordinates and make all the others sit in fixed positions. So again, I'm going to turn off my audio and give you guys about 5 minutes to work on that. just as a quick note, some people asked for extra time on this exercise, so we are doing that. I'm just going to give you another couple minutes to work on this. So you have another couple minutes, and then we'll resume. Okay, we are going to move on here, but don't worry if you didn't finish this. You will have more time to work on it, because what we are moving into next is actually another exercise. So this exercise is our final exercise for today, and this is, in fact, the last thing that we have prepared for this presentation. So this exercise, we would like you to create a function called draw dartboard. It draws a dartboard on the screen. So what you should do is design this function so that it takes the following parameters as inputs. It should do the location of the dartboard and the diameter of the dartboard. So you should call the function draw dartboard to be at your mouse X and mouse Y, and with a diameter of 100. And then you can set your ring size however you want, and your colors however you want. Again, please do feel free to join in to some of the chat channels on Discord. Before I transition off of this and let you guys get to work on it, we do just have some other stuff that we want to say. So this is the end of the content. We've made it through all 6 of our slide sets that we have prepared for this year. So what's next? Um, so, due to the problems caused by COVID-19, the project that we typically have you all do at the end of the sessions is optional this time around. So typically we have people build a game or a data visualization thing, and we strongly recommend that you do that. On a personal note, that's how I learned programming languages. I can code in about 25 different programming languages, and I learned every single one of them by finding a project that I wanted to do and writing it in that language. It's an absolutely unbeatable way to learn these things. Um, so I really, really personally strongly recommend that you, even if you don't share it with us or if you don't get our help with it, I really recommend that you build a game or a data visualization thing, um, because it's a fantastic way to learn things. So if you do want to build a game or anything, please do join us on the Discord. You can find partners to work with. You can ask questions of the mentors who will be available for the next 2 weeks at least. You can show off your work, hopefully, once Discord starts behaving as far as uploads go. Um, but yeah, please do. We would love to see all of that. Um, so yeah, I'm sorry. Richard's also sent me some other stuff to send to say that's not on these slides. So my apologies. Oh, also, if you do a project and you finish it, we will give you a shout out on our Instagram thing. I don't use Instagram. I don't know how it works. Um, so yeah, if you are interested in doing the project, please do message the Discord. You don't need to have a project ready. You don't even need to have a project in mind. We're just interested in how many of you would be interested in doing projects, because it's obviously been a really kind of stressful and chaotic time, and we're kind of trying to adapt, and we're trying to see how this model works for people. Um, so we just want numbers to see how many of you are interested in doing a project. Um, if, on the other hand, you are interested in learning more about Python and processing, so there's a bunch of stuff we didn't cover that you may have seen in some documentation, stuff like dictionaries and classes and objects. Um, so please, again, also send messages on Discord. If there's enough interest, we'll put together a set of slides. We'll talk about that. Um, if it's just one or two people, we probably won't, just because it's a lot of work for us to put together these slide sets. So if it's just for one or two people, it's probably just easier to explain it in a chat, which is kind of unfortunate because it's always really nice to do these streams and these presentations, but that's how it goes sometimes. Yeah, that's pretty much it. Uh, you can see here we have a couple of games that I wrote last night. The one on the left is called Flappy Block. You may think that it's derivative. If you do, I have no idea what you're talking about. It's completely original, and I think that that's a multi-million-dollar idea and project there. On the right, that one is just kind of a top-down, just a thing. So you move around using the keyboard, and you shoot at the incoming shapes using the mouse. So the code for both of those is on our Google Drive. Please do feel free to have a look at those. If you want to see kind of how I do things with that. You've already seen a lot of my code this past few months, but if you feel like seeing some more of it, those are some excellent examples. And they do have some interesting stuff in there that could be quite useful for any projects that you felt like doing. But again, that's pretty much all we have for you. So I'm going to transition back to our exercise slide, so that you all can work on this. Again, please do join in on the Discord to talk about how to do these sorts of things. We'll have some mentors in the chat. I will probably join in at some point. Yeah, so we have some time for you guys to work on stuff. We'll be here at the very least for the next half hour. And we're pretty much always available to answer questions. So again, if you do have them, please do post them. We'd love to help you guys as much as we can. But that's pretty much it for the content today. I'm not sure if I'll talk about anything kind of more advanced after this. I don't think so. But yeah, we'll just work on this exercise on the Discord. So thank you all for watching, and good luck working on this exercise.